Hi everyone, I'm daoda Zhang. Today I'm going to give a presentation about the effects of various reinforcement on the mechanical properties of soils. Before the start, I will give a little explanation about my topic. As you see, that is a very big topic. There are many different mechanical properties of soils, such as elastic properties, plastic properties, soil mechanics, and in the different soils it will be different behavior. Therefore, I choose one aspect to analyze the mechanical properties, that is the multi-tiered returning walls design and application. And that is the abstract of my topic. The first one is the outline the topic, and the second one is the importance of my research. The third one is which way I use in this research, and the third one is the findings I find, and the last one is conclusion. Well, next is the table of contents. There are 4 parts in my research. The first one is the introduction, and the second one is the lecture review. The third one is the axiomate design, and the last one is the reference list. Now we're going to the introduction. The research question is how to design and calculate of the multi-tiered returning walls. And in the introduction, I will give you the significant reasons of my research. It contains 2 parts. The first one is the value of multi-tiered returning walls, and the second one is made of a complete set of the system theory. With the development of the infrastructure worldwide recently, the more and more high field scope engineering, especially the construction of the railway, highway, and airport in the mountain area. So, how to reduce the cost and the construction difficult, and again application, the stepped returning walls reinforcement which bears in itself the adventure like the perfect structure performance, uniform wall stress contribution, and the deformation resistance is greatly induced into the construction. In secondary, there exist many researches on the step reinforcement earth railing walls, a completely and short theoretical codes, and the specification is for now still unavailable. However, only HFWA and the NCMA has some simple regulations about the double grade reinforcement returning walls based on the different assumption. There are even no clear codes for the design of steps reinforcement earth returning walls in Australia. Alright, the next part is the literature review. There contains about 3 parts. The first one is the research on the design method for the stepped reinforcement earth returning walls. And the second one is the research on the structural behavior of the stepped reinforced earth returning wall. And the last one is the subject analysis. In the first part, I introduced the FHWA's method. This structure overall stable design method is carried out according to the stable calculation mode of scope. However, FHWA method fuels the introduction of the design method for those that reinforce the Earth's returning wall with more than 2 grades. And then I introduced the NCMA's method. The interaction between the upper and the bottom walls is negated when designing the upper walls, and the upper walls is equivalent to the uniform X load acting on the bottom walls on the top when designing the bottom wall. I also gave other 5 research and analyze their advantage and disadvantage. Okay, the next part is research on the structural behavior of the step-reinforced Earth returning walls. The research on the structural behavior focused mainly on the laboratory and field test study. We analyzed the vertical stress, wall back, horizontal earth pressure, and tiered reinforcement deformation chapters of the double grade reinforcement returning walls in the north area. Based on the full-scale experiments of the double grade reinforcement returning walls with a height of 5.6 meters, you explain the horizontal deformations of the walls and the strength of the tier-rail reinforcement. It turned out that the interaction between the upper and the bottom walls had a profound influence over the overall structural behavior. Also, he found that the tiered reinforcement tennis force deduced from the FHWA method was higher than its real value. You also conducted a comparative study of the 2 American popular designs of methods, the NCMA and the FHWA, while the numerical simulations. The next key explored the influence that the factor including step widths, the wall height, the filter, the foundation strength, and the precipitations had over the structure engineering chapters, while the lab model test and the numerical simulation. You also proposed that the vertical platforms dedicated one considering the interactions between the upbound walls was far less than deduced from the FHWA's method, while the FEM analyzed the dynamical behavior of the single tier-rail and the multi-tier-rail reinforcement earth returning walls with a height of 9 meters. More precise, they analyzed the influence that the steel bars length and the concerning of the space may have. Okay, the next part is subject analysis. Because there has many significant meaning for this subtopic, I decided to research on the multi-tier-rail reinforcement to find out how to have a good design and calculate with the multi-tier-rail returning walls. The third part is the research design. I designed 4 models in different steps, and the equipment, like the instrument of the displacement, test box of stress, compressive equipment of taking static load, and I use the way adding 20 kPa every 3 minutes to giving experiments. I also want to introduce the three models. The module A is multi-tier with retaining walls, and its length is 3 meters, the width is 1 meter, and the height 1 is 0.6, and height 2 is 1.5, and height 3 is 2.1 meters. The width of steps is 0.25 meters. And the module B has the same length, the same width, the same height in the wide, but the wide steps is 40, and the same as the module C, but the module C is the wide of steps is 80. Okay, that is the data from the experiments. So in 3 tables we can see that yes, we can see that in the different nodes, it can be found that with the increasing load, the vertical load of the basal stress is almost unchanged. Our 3 tables also show that under the load, the lateral and vertical deformations of the walls are relatively small. Indeed, the up returning walls have a little structural influence over the bottom ones. And I also have another 3 data with these experiments. In these 3 data, we can find that a little loads have been changed in the different nodes, and in the basically is almost stable. So we can conclude that with if the step wide helps greeting that the upward loads act outside the Columbial written Bolton's walls, the basic stress is relatively small. Also, the lateral and the vertical demarcation of the walls are relatively small. Indeed, the up returning walls have little structural influence. And in my research, I referred to 25 references as guidelines. So that's my presentation. Thank you.